Hello, everybody. Hello, everybody. Today we're going to be talking about properties of matter. Let's go ahead and get ready to take some notes. First thing we want to talk about is what is matter. So let's review a little bit. Matter is the stuff that makes up everything in the universe. And we talked also last time about different types of mixtures, whether it's a pure substance, things of those nature. Okay, so matter is everything that exists in the universe. And so let's look a little bit more about different characteristics of matter. Okay? First thing I want to talk about is the physical properties. Okay? Of what is a physical property? A physical property is any characteristic of a material that you can observe. It's observations that you can make. You have five senses, and you can use them, all right, to make observations. Color, shape, size, density, the melting point, the boiling point, these are all physical properties. Appearance. Appearance is also a physical property. The appearance is describing its shape, the color, the state of matter that it is. Remember, we have four states of matter: solid, liquid, gas, and plasma. Look at that. What do you see? Some will automatically say, well, it's a soccer ball. Other people may say, well, it's a ball. And then other people may say, well, actually, it's a spheroid object made up of all these hexagonal shapes stitched together in a pattern. And all of you would be correct. It just depends on how deep and detailed and your familiarity with different objects. Another physical property that we talk about is behavior. What is it doing? Describing a property such as it being magnetic, the viscosity of an object, the malleability. Just know malleability is the ability to be bended or shaped. Okay? Physical properties can also be used to separate mixtures. Remember, a heterogeneous mixture, these are things that are mixed together, but there's no chemical bonding, there's no compounds being formed. And so we can use physical properties to take apart mixtures. For instance, it shows someone here sifting flour, getting out different impurities and things of that nature. That would be using the physical property of the size of the object. Physical change. What is physical change? Physical change is when there is a change in the size, shape, or the state of matter, but the substance still stays the same. So for instance, you have a chunk of Play-Doh and you cut the Play-Doh in half. It's still Play-Doh. We change the shape of it. It's still Play-Doh. Okay, but those are all physical changes. We change the size, the shape, or even the state of matter. We can melt the Play-Doh. All right, maybe not a good example, but we could freeze it and turn it into a solid. Okay, it let the Play-Doh dry. It's still Play-Doh. It's just now instead of being malleable, it's now very solid. Okay, using the physical change, we use this to make usable products. For instance, drinkable water. We can boil the water to remove impurities, and then once it's a vapor, we evaporate it back into water, and then it's very pure. We also do this with gasoline. We use a distillery and we use heat, and we can separate out all of the things that we don't need. And you can see on this little picture on the right hand side, it shows like what level of purity gasoline is at the top versus like diesel for your cars. Um, and the amount of energy required and the heating that is required for that to happen. And we use the physical change. Both examples are distillation. This is the process of separating substances by evaporation and condensation. All right, so if you buy distilled water at the grocery store instead of pure water or purified water runs through a filter. Distilled water, it boils it, evaporates it, and then condenses it. Okay? It's a pure type of water, and this little picture of how it happens. A laboratory distillation device. Okay. Chemical properties. Talked about physical properties. Let's talk about chemical properties. A chemical property is any characteristic of a material that produces one or more new substances. This is the ability to make something new. Okay. For instance, flammable. If you burn something, we're burning wood, for instance, we're turning that wood into carbon dioxide, we're turning it into smoke, we have ash, different things like that. Okay, so we use the chemical property of the wood to turn it into something else. The acidity of something. We have an acidic substance, say even citric acid, that we can get out of fruit. We drop different items in there, and it can change whatever that characteristic that been dropped into it. Okay, changes it to a new material. Medicine or the reactivity. Medicine is used because it has chemical properties that can bond and combine with different compounds in your body to produce different results. Another chemical property is chemical change. This is the change of one substance to another. Okay, and we know that chemical change is taking place because we have our senses. We can smell something cooking. That's actually a chemical change. We hear different things. You might hear a pop, a bang, an explosion. You may see fizzing. Okay, you may feel something. There's heat given off. There's a chemical change going on. Okay. And again, a clue to a chemical change is also changes of state that are happening because reactions require energy or some reactions give off energy. Some different things may take place. Okay? So a physical change in nature. There are natural physical changes. Weathering is one of those things. It's a physical aspect. There is erosion, there's freezing and thawing. Water gets into cracks. The water freezes and expands, it brings the crack wider open. Smaller pieces are chipped off. Different compounds and chemicals are wore out of it. Chemically, there's several different compounds. Notice chemical weathering. We see a lot of these types of rocks in the Black Hills where rain and water has run over it and it washes and cleans out, in essence. But over a long period of time, it wears out the softer material that's in those rocks. And then what's left behind is these very grooved and channeled rocks because the water or other types of things have reacted and caused different things. Okay, so there are physical changes in nature, weathering, and there are physical weathering and chemical weathering. Conservation of mass is also really important, so we're going to touch on that here. Just know that the law of conservation of mass says the total mass of the reactants has to equal the total mass of the products. So whatever goes into a reaction, that mass has to be there when it comes out. And this was really a fundamental breakthrough in science because up until then there was these mystical things that they thought were happening. You add some magical substance to it and poof, you get some new substance. And a lot of experimentation went into realizing that if you have a sealed system where there's nothing can escape, and you do a reaction, that weight is not going to change even though things are changing inside of that system. Okay? That's called the law of conservation of mass. And we know it today as matter can be neither created nor destroyed. Everything comes from something.